So geometric optics would deal with the study of light and its properties. The very first thing they have given us here is, let's walk us through this one. I wanted to magnify it, but okay. The very first thing they have said in the learning outcome is to know about normal, incident angle, reflected angle, and law of reflection. So this is the surface on which some incident light is coming. The point at which it touches the surface, we draw a 90-degree angle with the surface. This line is known as normal. This ray traveling towards the medium is known as incidence ray, incident ray, sorry. And the angle which it makes with the normal is the incident angle. Similarly, the ray traveling away from the medium is the reflected ray, and the angle which it makes with the normal is reflected angle. And according to law of reflection, incident angle is equals to reflected angle. This is the law of reflection. But this only happens if the surface is smooth. That means there is no irregularities in between them. Suppose the incident angle drawn is 40 degrees, the reflected angle would also be 40 degree, only if the surface is smooth. There are two types of reflections, that is known as regular reflection, that happens on the smooth surface, and irregular reflections that happens on the rough surface. Apart there is a possibility कि कुछ light भी उसमें क्या हो सकती है, absorb हो सकती है while this happens. The next point is solve the problems of the image by location spherical mirrors using mirror formulas, and define the terminologies for the angle of incidence and angle of refraction. Describe the passage of light through parallel sided transparent material. अच्छा जी, पहले ये बात कर लेते हैं कि solve the problems of image location by spherical वो. So whenever we talk about the image formations, there are certain things that we keep in mind, especially for the mirrors, that the distance of object and the distance of image would always be equal. That is, these two distances would always be equal. And the total distance, for example, if this is 5 centimeter, this would also be 5 centimeter. So distance from the object to mirror and mirror to object is always equal. Second thing is the law of reflection again applies to this one. Any two random rays, they would be like this, traced back to meet at the point where image would be formed. Again, law of reflection local is incident angle and reflected angle is equal. Similarly, incident angle and reflected angle is equal. So the image formed would be virtual image. And why it would be a virtual image? Because rays of light are not actually meeting here. We could clearly see कि हम लोगों ने इनको trace back किया है. I trace back these rays to this point to form the image. So such an image is known as virtual image. So object distance should be equals to image distance from the mirror. Second is image is formed right in front of object. It would never be formed on any other side. It would right in front of the image. an image would be of the same size. ये virtual image की properties होती हैं. Same size, upright, or we can also say it laterally inverted. That is something that will. So all of these, we do it with that. And then we have the last topic that we're going to discuss today is the parallel-sided transparent material. For parallel-sided transparent material, let's consider this. Incident ray would come, we would draw a normal. The ray would be refracted, incident ray, and this one. Now, what is refraction? In refraction, रिफ्लेक्शन में तो मीडियम चेंज नहीं होता, ठीक है. मीडियम रिमेन सेम, सो स्पीड, फ्रीक्वेंसी एंड वेवलेंथ कांस्टेंट रहती है हमारे पास. बट रिफ्लेक्शन में डिफरेंस ऑफ मीडियम आता है, मीडियम चेंजेस. ड्यू टू दैट चेंज ऑफ मीडिया हमारे पास reflection occurs, and refraction is the bending of light from its original path. Here we could see if there was this medium was not present, the light would supposed to go like this, but it bended like this. I should not draw it using this, I should draw this. So this would have been the straight path of the light, but due to difference of medium, it bended towards normal. So whenever light is entering from air to glass, in which I should write it down, air to glass, in air, the speed, the wavelength would be greater, and in glass, it would be smaller. And incident angle would be greater than refracted angle. Now this is refracted angle, not reflected angle. So ray would bend towards normal. Towards normal mean it would make a smaller angle, but it would enter the light. And away from normal, it would go. Since it's entering from glass to air now, again the opposite thing would happen. The only thing that we need to keep in our mind is that these two incident, this incident and this ray, the refracted ray would be parallel to each other always. Okay? So this is the incident angle, this is the refracted angle, towards normal, away from normal. Here, when it's entering from glass to air, the opposite would occur, that now the incident angle would be smaller than refracted angle. Are we clear?
Yes.
Yeah.
So we discussed about reflection and a very brief discussions regarding refraction. We're going to discuss this in detail. Reflection का काफी extended version है. This all these 3 points ना. Equation sin I over sin R, conditions for internal reflection, the passage of light through a glass prism, how total internal reflection occurs, and how light is reflected through lenses, power of the lens. ये सारा portion would be covered in refraction part ना. So there is a lot to be discussed regarding reflection. For now, I have only given you the basic meanings of reflection and reflection. What is reflection? It is the, how do we define reflection? Bending of light into the same medium. So, no change in velocity, frequency, and wavelength. Whereas, how do we define refraction? Refraction is defined as the bending of light due to difference of medium. लाइट की स्पीड नॉर्मली हम लोगों ने पढ़ी हुई है, स्पीड ऑफ लाइट क्या होती है? इट इज रिप्रेजेंटेड एज c and it is 3 into 10 raised to power 8 meters per second, which we have this value same for air and vacuum. Since it enters to some glass parameter, so these values would change, which we will obviously study in detail in the with each topic, with each next topic. Clear up till now? Angle of incidence and
Yeah.
reflection, angle of incidence and refraction. So these are two different things, and the values would change when we enter from reflection to refraction. And the reason behind that is K. The reason of changing all these points is K. Because जो change of media occurs. Due to this change of media, we have these values changed. Okay.
Okay.
And this incident and this reflected angle is mostly equal to each other, which we'll study here in this chapter as well. Any question up till now?
No.
We know that the light gives us energy to see around things around us. So basically, let's just start me baat boliye. The sense of sight is extremely important to us, for it provides with a larger part of information about the world. How do we see? With the help of light, enters our light and causes a sensation of sight. This is what the definition of light is. Light is a form of energy which gives us sensation of VN. Sight, VN, same things. So the very first thing, reflection of light is a phenomena of light bouncing back after falling onto an object. We see object if light reflection from it enters into our eyes. The following terms are used describing the reflections of light. The ray coming towards the surface is incident ray. The ray bouncing off the surface is reflected ray. The point of incidence is the point at which the incident ray strikes the surface, and जो नॉर्मल ड्रॉन होता है, एज मैंने आपको एक्सप्लेन किया था कि दिस इज द, ये इंसिडेंट रे है, दिस इज द पॉइंट वेयर वी ड्रॉ द नॉर्मल, एंड इफ दिस इज द रे, दिस हमारे पास नॉर्मल है, दिस इज नॉर्मल, एंड दिस इज द रिफ्लेक्टेड रे, इंसिडेंट रे एंड रिफ्लेक्टेड रे. Angle of incidence and angle of reflection respectively. So this is angle of incidence and this is angle of reflection. Incident angle and reflected angle would always be equal to each other. They have shown this in the diagram as well of the reflection through the mirror, which is this is the surface, the mirror, incident and reflected, and we measure it with the help of D. बेसिकली हम लोग क्या करते हैं कि हम लोग एक मिरर लेंगे, यहाँ से एक रे बॉक्स होता है एक, वहां से हम लोग ना रे ऑफ लाइट को इंसिडेंट करवाते हैं ऑन टू द मिरर. तो जब वो इंसिडेंट होती है मिरर के ऊपर, ठीक है, ऐसे हमारे पास ना ऐसे इमेज आ जाएगा, हम उसके अगेंस्ट ना पेंसिल से ट्रेस कर लेंगे उसको. लाइक मेरे पास ये मिरर है, ये रे ऑफ लाइट आ रही है, एंड आई वुड सी दैट कि वो ऐसे यहाँ पे हो रही है. अब ये इमेज हमारे पास जब बन जाएगा ना इस तरह का, हम लोग उसको विद द हेल्प ऑफ पेंसिल्स जो है ना ड्रॉ कर लेंगे. फिर हम लोग रिमूव कर देंगे सब चीज़ों को, एंड देन हम लोग मेजर करेंगे कि अच्छा जी यहाँ पे 90 एंगल था, इसको मेजर करेंगे, इसको मेजर करेंगे, एंड इफ दीज एंगल्स आर इक्वल टू ईच अदर, द लॉ ऑफ रिफ्लेक्शन इज validated. So the first law is defined as the incident ray, the reflected ray, and the normal to the surface all lie in the same plane. As you could see, they all lie in the same plane of reference. The angle of reflection equals to the angle of incidence. And the next topic, we have spherical mirrors. We have two types of mirrors, concave and convex. They both are the part of the spherical mirror. The concave has inner curved surface and convex has outer curved surface like this. So concave looks something like this, and convex looks something like that. Its outer surface is outward, na? Like you could see here. If I refer to this diagram, na, it has the inner reflective surface, the concave mirror, and convex mirror has the outer reflective surface. So they both are the part of the same. These are the terms that you need to remember and memorize when it comes to mirror. This would remain same for the lenses as well. Okay. So center of curvature is the center of the sphere of which the mirror is formed. Center of curvature is the center of the sphere. Let me this center of the sphere. Radius of curvature is the radius of the sphere of which the mirror is a section. Vertex is the midpoint of the spherical mirror. Principal axis is a straight line. This is principal axis, which is passing through the focus point and center of the mirror. This is the spherical mirror. This hole is a spherical mirror. You could see here. This hole is a spherical mirror. इसका center जो है, it would be center of curvature. And the radius from this radius तो same ही रहता है हमारे पास, ठीक है, on either sides. This radius as written here as well is the radius of the mirror, and this is the focus point. Focus point is the point known as the after passing through अब जैसे तो convex and concave lens है ना, concave spreads out the light, whereas convex mirror converges the light. That is अगर हम mirrors draw करेंगे, when the light would fall on it now, if it's like this, the rays, parallel rays are coming towards the lens kind of mirror, they would diverge after passing through the lens. And if it's a convex mirror, I'm very bad at drawings, उसका outer surface जो होता है वो reflective होता है. So when the rays are coming towards it, it would converge it to a point. This is the focal point, sorry. When I would trace these light back, na, they would meet the point. So it's a virtual point for concave and it's a real point for convex lens. These are incident rays. Whenever ray passes through the center of the lens, it goes undeflected. Center of the mirror. Okay? So these are the incident rays and these are the reflected rays. So diverging के बाद when we trace these backs, so they meet at a point which is known as focal point. Similarly, for convex mirror, after these are the incident rays again, okay, and when they after reflecting from that surface, they converges to a point. That's why it's also known as converging mirror and diverging mirror.
Okay.
Clear? And the principal axis is the line that passes through the focal point. And focus point भी कहते हैं, focal point भी कहते हैं, focal length होता है basically the that we're going to do in the next topic as well. शायद उसकी definition लिखी भी हो. Yes. Here you could see the diagram which I just explained to you. Okay, there are two types of lenses. ठीक है, उसकी इनर एंड आउटर सर्फेसेस जो होती हैं, ये हमारे पास पोल हो गया, ये फोकल पॉइंट हो गया, ये सेंटर ऑफ द लेंस हो गया. दिस लाइन इज नोन एज प्रिंसिपल एक्सिस. सो कनकेव के थ्रू जो है हमारे पास, सॉरी आई सेड द ऑपोजिट बट एवरीथिंग इज सेम. कनकेव मिरर के अंदर जो है दे मीट आफ्टर दिस एंड कन्वेक्स के अंदर दे डाइवर्जेस. लेंस में इसका ऑपोजिट होता है. आई ऑलवेज मिक्स दीज अप. ठीक है, it's the virtual point and the rays are actually meeting here. So this is the real point and this is the focal length, which from the pole to the focus point is the focal length. Okay, and it is the equation होती है 1/f is equals to 1/p plus 1/q. for lens, और जो मिरर्स की होती है वो भी आई गेस अप्रोक्सीमेटली ऐसे ही होती है हमारे पास. This is height of image, distance of object, distance of image. That we'll do in the next topic. For now, go ahead and give it a review. Let me know if you have any questions. जो focal जो focus points होते हैं ना, if they are virtual, they are taken as negative. If they are real, they are taken as positive. So for concave mirror, they are actually meeting here, so it would be a positive one, and it would be a negative one for concave convex mirror. They might have mentioned the next topic as well. When go to that topic, we will discuss. Magnification is basically the height of image over height of object. ठीक है? Or distance of image over distance of object. And since यहाँ पे negative का sign, whenever wherever we use a negative sign, it means के the images forms or whatever the thing is, it's virtual, not real. And virtual means के rays are not actually meeting there, but we have we say के I forgot the term used for it. Trace back. We trace back those rays to form that image or anything. So negative sign in this chapter would only mean something is virtual. It's not actually meeting there, but we are tracing it back there. So in the previous lesson, we discussed about how concave and convex mirrors are the part of a spherical mirror from which it is uh, taken out from. उसकी जो रिफ्लेक्टिव सर्फेसेस होती हैं, उसकी इनर एंड आउटर कर्व सर्फेसेस जो होती हैं वो रिफ्लेक्टिव होती हैं, एज यू कैन सी इन दिस एज वेल. There were few points that were not clearly written in the other book. So this is what I was talking to you about in the previous lesson, that incident ray, the point at which it touches the surface, that at that point we draw the 90 degrees angle. This line is known as normal. The angle which it makes with the normal is incident angle, and the line angle it which makes with the reflected ray, it's the angle of reflection. Always make sure, though it's not a conceptual based subject in this case, but never take these two angles with respect to the rays. Okay? The normal incident angle and reflected angle would always be between the normal and the ray, never between the surface and the ray. So we would never make that mistake कि हम लोगों को उस तरफ उसकी वो mistake हो हमारे पास. Okay? And here is a definition of reflection, which is a good definition. When light is incident onto a medium and it bounces back into the same medium, such a ray of light is known as when light is traveling in a certain medium and falls onto the surface of another medium, a part of it turns back into the same medium. This is known as reflection. And then we have law of reflection. The law of reflection tells us that the incident ray, the normal, and the reflected. Yeah, this is the previous thing that we saw in the previous chapter. It's the same in this book as well. These are the types of reflection. It was not mentioned in the other book. So this is the regular and irregular reflections. Smooth surface reflections are regular ones, and when we have a surface which is not smooth, rough, we have irregular reflections. Then we do not have that law of reflection is not followed in that. The surface of it reflect the light of rays in many rays. Such type of reflections is called irregular reflections. Then it comes the principal axis, the line which passes from the center of curvature and the focus point, and both for the same convex की outer surface जो होती है वो reflective होती है, concave की inner surface जो है वो reflective होती है. As you can see here, a spherical mirror whose inner curved surface is reflecting is called concave mirror, and a spherical mirror whose outer surface is reflective is the convex mirror. Kal by mistake we said the opposite thing. So concave mirror, the images, the rays are actually meets to a medium. So the image is normally formed by are real. But again, this is the important point that the virtuality or reality of an image only depends upon the position it is from the focus point. Okay? Similarly, it's the same thing, only virtual and erect images formed by the convex mirror. Convex mirror normally forms virtual images. But in concave, we can both have real and virtual image depending upon the position of the object. That we'll discuss in detail. Pole हमारे पास क्या था? Midpoint of the curved surface of a spherical mirror. It's called vertex, and curvature क्या था? Spherical mirror is a part of sphere. The center of sphere is called the center of curvature. Radius of curvature, and this हम लोगों ने सब डिस्कस कर लिया था. Principal focus वाला पॉइंट ये कि where the rays meet after reflecting from the surface, concave mirror rays of light parallel to principal axis converges to a point which is called the principal focus. Hence, concave mirrors are also called converging mirrors. और लेंस में जब हम जाएंगे इट वुड बी द ऑपोजिट. मैंने बाय मिस्टेक लेंस का लास्ट टाइम जो था डिस्कस वो एक्सप्लेन कर दिया था. These properties would turn to other sides when we are going to discuss the lens thing. तो वहां पे आपने बस इस चीज को याद रखना है. Since rays, this is the important point which I was telling you, कि since the rays are actually meeting, so actually pass through this point, these are called real focus, whereas convex mirror में वो actually pass out नहीं करती, इस वजह से हम उसको कहते हैं virtual focus. Here is convex mirrors are also called diverging mirrors. That the principal focus of a convex mirror is virtual because the reflected rays do not actually pass through it but appears to do so. हम उसको trace back करते हैं. ठीक है? These उन्होंने ये उसके image show किया हुआ है कि this is the image which we normally get. Sorry, the diagram. Principal focus, center of curvature, vertex or pole. The line which passes through this one is known as the principal axis. Radius of curvature वो हम लोगों ने सब डिस्कस कर लिया था. From center of curvature to the surface is the radius of curvature, and focal length is from the this. You could see here it is a distance from the pole to the principal focus measured along the principal axis. Here you could see the focal length. This is the focal length from focus point to the center of the lens. अब ये these are the important points. Convex lens focus lies behind the mirror, focus in front of the mirror. The focus is real as the rays actually converges, and this is virtual because we need to trace them back like this. We have to trace these back to this point. Parabolic mirrors are used in the headlights extra reflection of light. बाकी कल मैंने आपको बता दिया था कि P is the distance of object, Q is used to symbolize for the distance of image, and F is the focus. For real, it's considered positive, and for virtual, they are considered negative. आगे टेबल में वो डिस्कस भी होगा यहाँ पे. उन्होंने यहाँ पे एक एग्जांपल भी दी है कि porous pin act as a convex and concave mirror. मतलब जो उसकी inner curve surface होगी वो it would act as a concave, and the outer surface. You could see the image in this diagram. It's erect. Erect का मतलब ये होता है कि if the object is placed like this, the image would also be like this. And here we could see the inverted image. ठीक है? मतलब object was placed like this, but the image formed was like this. तो उन्होंने यहाँ से एक अच्छी example के through ये just मतलब point भी again explain कर दिया इन लोगों ने. ये पोल उन्होंने यहाँ पे डिस्कस किया हुआ है, उधर ऊपर वाली डायग्राम में डिस्कस नहीं था. सेंटर ऑफ कर्वेचर. Here for convex mirror, focus and center of curvature lie behind the mirror, not in front of the mirror. You could see here it's behind the mirror because this is the reflective surface, not this one for convex lens. Okay.
Okay.
Here the law of reflection is discussed with respect to convex mirror, that incident ray equals to reflected ray, and everything that we discussed. Yeah, same for concave. Again, the only thing that we need to keep in our mind is the outer surface and inner surface is reflective. This is the formula that we normally use to find out focal length, distance of object, and distance of image normally. Okay. And again, जो virtual and वो real image only depends upon the distance of the object from the focus point, which we're going to discuss in this topic. Are we clear up till here? Power of the lens भी
Yes.
हम लोग यहाँ पे पढ़ेंगे,
Yeah.
power of the mirror भी पढ़ेंगे. That would have the same meaning. This is an important thing. Let me circle it out for you. That in large shopping center आपने normally ये देखे होंगे big malls के अंदर लगे हुए. These are mostly convex mirror, are used for the security purposes. We can see the whole area with it. The focal length of a spherical mirror is 1/2 of the radius of the curvature, that is S is equals to R over 2. However, we take the focal length of a convex mirror as negative. Why do we take it negative? Hareen?
Because it's virtual.
It's virtual. It's not actually there. We have traced it back. So उन्होंने यहाँ पे वो reason दिया हुआ. So basically the focal length is half of the radius of the curvature. This is the formula उन्होंने theory यहाँ पे discuss की. This is a very important table that would come in handy in exams for numericals and MCQs as well. So object is written as P, image is Q, and F as focal length, as I explained to you before. Real object, real image, concave, virtual, virtual image, convex. ठीक है? Focal length of concave is positive, so उसका image real होगा. Focal length of convex lens is negative, so उसका object and images जो है वो virtual बनेगा. Sorry, image virtual बनेगा उसका. And अगर हम if we are putting a negative sign anywhere, that means that it is virtual, not real. For object, for an image as well. This is a diagram जो हम normally draw करते हैं to find out the image. There's a formula. Let's see this example. A convex mirror is used to reflect the light from an object placed at 66 centimeters. So P is 66 centimeter. F is 46. We'll use it as 46 or minus 46. We'll take 46 as positive 46 or negative 46.
Negative.
Because it's a convex mirror. उसने start में हमें ये discuss करवा दिया. We need to find out the distance of image. That is Q हमें find out करना. So उसने equation already rearrange कर ली हुई है according to the situation. 1 over F is equals to 1 over P plus 1 over Q is the equation in general. And we place the negative signs as per the images. Now, focal length 1 over 46. This answer came out of 1 over 27. We need to find out Q. So Q is minus 27. That shows the image formed by the convex lenses virtual. Similarly, एक concave lens की example है, object का distance दिया हुआ है, focal length दिया हुआ है. अब यहाँ पे हमें again Q find out करना है, but this time F would be positive. So Q is minus 15, which means the image formed by this is virtual. अच्छा, एक generic case होता है कि virtual image and real image basically depends upon the placement of the object जो हमने ऊपर पढ़ा था. ठीक है? Normally, whenever an object is placed inside the focal length, image formed is virtual. Whenever P is less than F, image formed is virtual. Reflection of light का portion है ये उससे related है, so we will not get into this one. Reflection basically I gave you the basic introduction in the previous lesson जिसके अंदर उसने हमें दिया हुआ था. ये convex mirrors produces image that are smaller than the object. This increases the view of the observer. एंड इफ यू रिमेम्बर यहाँ पे एक एग्जांपल थी सिक्योरिटी वाली, तो हम लोग उसका रीजन ये ले सकते हैं. यहाँ पे वी हैव गिवन द आंसर एज वेल हियर. ठीक है. अब डू यू गाइस मैच द आंसर्स, डू यू नो, एंड वो उसके अंदर उसका कंपैरिजन मिल गया कि वी कुड यूज दिस थ्योरी फॉर दिस वन. अच्छा, व्हेनेवर an image is formed, we need to keep into mind a few things whenever we form the image formed by the mirror, and that is distance of object from the mirror should be equal to distance of image from the mirror. Size of object is equals to, या और height of object इसको कहते हैं, is equals to height of image, and distance of object from the mirror is, let's say, P, and Q. They are equal when it comes to that. And they have traced back these images, raised, sorry, to form this image, which means it's a virtual image. And virtual image को कैसे identify करते हैं? It's always erect, which we can say upright as well. And normally the image is formed by images formed by mirror, normal mirror. We're not talking about concave or convex mirror. Okay, plane mirror की बात हो रही है. By plane mirror are virtual. Why are we calling it a virtual image? Who will tell the answer? Hareem,
Because it's behind the.
because the rays are actually not meeting there, we are tracing it back to that point. Okay? As I have at the start of the way lesson, I've given you the basic terminology. Wherever we are discussing virtual, it means the rays are not actually meeting there और हम negative sign use करेंगे. Now let's review this from the other lesson. Okay. So from the other book, we discussed that we just went into the equation straight away, which was 1 over f is equals to 1 over p plus 1 over q. That indicates that was for object, that was for image, and that was the focal length. That object, this is basically was shown कि ये this was the let me write down the equation. Yeah. 1 over f is equals to 1 over p plus 1 over q. This indicated the object distance from the mirror, image distance from the mirror, and this was the focus point. Now, इसमें height of image भी आ सकता है, height of object भी आ सकता है when it comes to magnification. तो as I was referring to these two diagrams and incorporating our information regarding the जो triangle theorems हम लोगों ने किए थे in the mathematics, we need to consider these two triangles, this one and this one. And we know that this angle and this angle is of 90. ठीक है? So हमने इन दोनों triangles को आपस में relate किया उनकी two sides and ये वाली इनको use करके. ठीक है? Similarly, this was passing through the focus point, it goes. आप लोगों को याद होगा हम लोगों ने कुछ पॉइंट्स डिस्कस किए थे उसके अंदर हमारे पास क्या था कि if it passes through the focus point becomes parallel to principal axis. So this is the incident ray, this is the reflected ray. Similarly, according to law of reflection आ गया incident angle and reflected angle. Since we could clearly see in this and according to math rules, this and this angle would be equals to each other because we know incident angle and reflected angle are equal to each other. These 90 angles are also equal. So we can easily compare this triangle to this triangle in a way that हमें इसको इस तरीके से करना था कि ये हमारे पास एक ट्रायंगल आ गया अब ये ऑल्टरनेट एंगल्स आ रहे हैं दीज एंगल्स आर आल्सो इक्वल अगेन वी हैव 90 डिग्रीज एंगल तो हमें इन दोनों को बेसिकली दिस वाज द फर्स्ट इक्वेशन इन रेफरिंग टू दिस ट्रायंगल हियर hi over इन्होंने नेगेटिव साइन यहाँ पे यूज किया है इन ऑर्डर टू शो दैट द object is in comparison to object the image is inverted so negative sign is that and these two sides DO basically उन्होंने ये sides and इन sides को compare किया this side and this side मतलब sorry let me use a different color for this one so that uh this was this side was compared of the triangle and these two sides were compared for bigger triangle this one and for smaller triangle it was again the common line this one ठीक है एंड अब यहाँ से अब इनकी वैल्यूज देख लो कि स्मॉलर साइज का इट वाज डी आई एंड फॉर बिगर साइज इट वाज डी नॉट तो ये हमारे पास फर्स्ट इक्वेशन आ गई इन रेफरेंस टू द फर्स्ट ट्रायंगल सेकंड में भी जब हमने इनको कंपेयर किया तो दिस साइड ओवर दिस साइड इज इक्वल्स टू फिर उन लोगों ने हमने ये साइड और ये वाली साइड को कंपेयर किया अब ये वाली साइड जो थी ये थी डी नॉट माइनस एफ की इक्वल एंड दिस वाज इक्वल्स टू एफ आर वी क्लियर अबाउट दिस सो फार फिर मैं नेक्स्ट पॉइंट पे
Yes.
जाता हूँ
Yes.
ये ट्रायंगल्स की साइड्स अगर आपको क्लियर हो गई हैं तो लेट्स जस्ट जंप टू द इक्वेशन जो हम लोगों ने डील करनी थी बेसिकली ये पूरी लेंथ जो है यहाँ से यहाँ तक ये जो पूरी लेंथ बन रही है दैट वाज डी नॉट बट हमें जस्ट ये वाली लेंथ चाहिए थी। सो एंड मैं आपको यहाँ पे इंडिकेट भी कर देता हूँ, नीचे वैसे शो भी हो रहा है कि दिस कंप्लीट लेंथ वाज डी नॉट, this only length was f. So if we wanted this length only from here till here, तो obviously it would be d naught minus f की इक्वल होगा। So जब हमने इन साइड्स को कंपेयर किया, अगेन हमारे पास दोनों इक्वेशन में कॉमन चीज क्या थी, h नॉट ओवर i। ठीक है, फॉर यू could see here it's common in both the triangles। सेम ही है, बस उसने एक ही डायग्राम को डिफरेंट टू वेज में डिवाइड कर दिया। ये बिल्कुल नहीं समझना हम लोगों ने कि दिस ऑब्जेक्ट एंड दिस इमेज इज डिफरेंट टू दिस एंड दिस वन। इट्स द सेम ट्रायंगल, सॉरी इट्स द सेम मिरर, द सेम रेज आर पासिंग थ्रू इट, बट उसने टू डिफरेंट साइड्स पे उसको कर दिया। यहाँ पे हम लोगों ने एंगल एंगल वाला ए एस वाला काम किया हम लोगों ने। ठीक है, ऑल्सो यहाँ पे हम लोग साइड साइड और एंगल भी हो सकता है हमारे पास। ठीक है, एंगल कौन सा कॉमन था, ये वाला। ऑल्सो दिस एंगल वाज ऑल्सो कॉमन। यहाँ पे ऑल्टरनेट एंगल्स वर इक्वल एंड सिमिलरली 90 डिग्रीज वाज इक्वल। अब दोनों में कॉमन क्या आ रहा था, रेशियो ऑफ एच नॉट ओवर आई। यहाँ पे एच नॉट ओवर आई की रेशियो किसकी इक्वल आ रही थी, इट वाज बिकमिंग इक्वल्स टू डी नॉट ओवर डी आई। यहाँ पे किसकी इक्वल आ रही थी, आई हैव रिटन इट डाउन, आई डोंट नीड टू रीड इट डाउन अगेन। For the second equation, it was coming out to be HO over HI was equals to D naught minus F over F, because हम इस triangle को consider कर रहे हैं। ठीक है, I put it in the equation, दोनों में मैंने direct ये लिख दिया है यहाँ पे कि H naught over I naught is equals to D naught over DI. This was equation 1, and H naught, a negative sign I'm putting there, is equals to d naught minus f over f. This was equation 2. This was from triangle 1 or diagram 1, sorry. I wouldn't write triangle. It was diagram 1. This was diagram number 1. And this is diagram number 2. यहाँ पे हमने कंपेयर किया इक्वेशन 1 और 2 को। So d naught over di is equals to d naught f. D naught over f over f would be equals to 1. ठीक है, after that, I rearranged the equation. I took 1 to this side and this to this side. So 1 is equals to d naught. अब d naught common आ जाएगा यहाँ पे, and we'll have 1 over f minus 1 over di. I divided this d naught onto the other side, and now we have this equation. और हमने उसको किस फॉर्म में लेके आना था, 1 over f की फॉर्म में. So we reached to this equation. I'll give you some time. You have your books in front of you, right? Okay. Magnification वाला जो point है, it remains the same everywhere. It could be the height of image over height of object or distance of image over distance of object. Let me clear one thing again here. Normally, the negative signs are used for the virtual images or something like that. And virtual images are mirrors के case में virtual images are the one which are formed on the other side of the mirror. ठीक है, and real images are the one which are formed on the screen. The example to these kind of images is a simple, as we see ourselves in the mirror. This is a virtual image. Virtual images have a certain indications. How do we compare virtual image with a real image in mirrors, Hareem? Lemma. Hareem, I guess
Virtual
sitting with this. Hmm.
virtual images are
That is, we reviewed these examples in the last lecture, no? If I'm not wrong. I think we didn't review these examples. Okay. We have a convex mirror of radius of curvature. They have given us a value of C. Let's install in shopping mall for security purposes to determine the focal length of the mirror. हम लोगों ने last time there it was given in the other book or on in the this one curvature versus radius का relationship कहाँ पे discuss था? I think it was in the other book. That's why I always ask you guys to review these things from both the books here. अब उन्होंने हमारी book में ये point discuss नहीं किया हुआ, but it was given in the other book for convex and concave. So let me take you to the book again. So from there we found the this thing, okay, since it was focal length for convex, so it's minus r by 2. We put this into the formula and we got the focal length, and then we use the formula magnification wise image और उस distance में 1/15 दिया हुआ. Rearrange किया हमने the whole formula and we found out the value of image which was minus 3.57. Minus 3.57 means what it would be? What kind of image this would be?
Virtual.
Virtual.
Yes. Then later on a magnification पूछा होता है last part में. So magnification is given by distance of image over distance of object. Distance of image was 3.57 and object distance was 15. And यहाँ पे negative sign नहीं add किया. What could be the reason for not adding negative sign?
I don't know.
You could see here if the for convex mirror the magnification is given as minus di over d naught. ठीक है? And for concave mirror it's
Okay.
given as di over d naught simple. So negative sign gets cancelled out with the negative sign and we have a positive. So positive magnification means it's an upright image. ठीक है? So the image is upright,
Okay.
same orientation. आगे उन्होंने explain किया हुआ है कि what is the meaning of upright image. तो वही वाली बात जो हमने पहले discuss किया हुआ है. Then the reflection of light, I gave you the bit of an introduction. उसमें हम लोगों ने बात की this fracturing that you could see here ना. Let's not circle this out. Let me zoom in for this image. You could see na this fracturing of the image. It appears like the pencil is broken. This fracturing of image is basically what refraction is called. Why is this happening? It is happening because change of media is occurring because it's air, it's water. So due to this change of medium, this bending of light, it was supposed to go like this, but it is going in this direction. So this bending of light from its original path, which I explained to you, this is the incident light, this is normal. And due to change of medium, instead of going to a straight path like this, ये normal आ गया. It was supposed to go like this, but due to the change of media, it deviated from its path. So एक line ऐसे बनता है. When this would be formed? When it's entering from air to water. So it would bend towards normal. Or we could also say rare to denser medium. ठीक है? When we go from rare to denser medium, the ray of light bends towards normal. That is, angle of incidence is greater than angle of reflection, not reflection. So it is defined, reflection is defined as the bending of light from its original path. हमारे पास क्या था? This was the original path, but it got deviated from its original path. This bending of light from its original path is known as refraction. And whenever it's entering from rare to denser medium, angle of incidence is greater than angle of refraction, and the opposite occurs in the other way around. That is, when it's entering from denser to rare medium, what would happen then? Angle of incidence and angle of refraction में कौन bigger होगा?
The refraction.
ठीक है? Why is that? Because speed of light is greater in air or vacuum. We're going to discuss tons of formula in reflection. The very first formula that we're going to discuss is with respect to these two diagrams. I'll draw these both diagrams. In this case, we have a formula n is equals to sine I over. This would be our last topic for today. Here, n is defined as the refractive index. Refractive index is defined as the ratio of speed. I should write it above because I will have more space there. Ratio of speed of light in air slash vacuum divided by speed of light in that medium. So n is basically the ratio of light in air over speed of light in medium. So it's also given as n is equals to c over v. C is for speed of light in air and v is speed of light in medium. What is the value of speed of light in air?
3 into 10 to the power of 8 meters per second.
And it will always be constant. Okay? It would never change. So the only thing the examiner would ask us either to find the refractive index or the speed of light in that medium. So the ratio up we could see here, it has an inverse relationship. Okay? It's very clear that speed and refractive index has inverse relationship, which means if refractive index is bigger, speed of light would be smaller, and matter speed of light would be much slower, and the vice versa. So are we clear about these two formulas? N is equals to C over V and N is equals to sine I over sine R.
Yes.
We use this formula whenever we are entering from rare to denser medium. And the opposite formula would be for this one, whenever we are entering from glass to air, away from normal. The arrowhead symbolizes that. So this is when denser to rare medium, which means obviously speed would increase. मैंने ये mention out कर दिया था ना? Speed of light is greater in vacuum. Yes, I have mentioned this out. This all is happening in context to this one. Okay. So here the formula would be, if I've already told you that it would be the opposite. So what would be the new formula? Harim, can you give me the answer? N is equals to Harim or Lemma. What
Would
would be
it be
the
the
formula?
reciprocal?
Yes, sine R over sine I. So whenever we do these calculations, we will always check because we already know what would happen when it enters from denser to rare medium. So whatever the calculations we need to make, okay, we would know the idea in this particular formula, sine I would be smaller than sine R. And whenever we are using this formula, sine I would be greater than, not sine I would be greater than R. And similarly, we know that okay, whenever we are discussing in context to some medium, this value would always be smaller than this one. So these are the checkpoints that we'll use to make sure whether we are doing the right calculations on. Clear?
Yes.
Now let's review what our book has to say. The same points are repeated again. Okay. Incident ray is approaching the ray of light before refraction, after refraction, point of incidence, normal, angle of incidence, angle of refraction. They all have the same meaning. This, oh, and again, I repeat one more time, we would always take these two angles, never with the surface. These will be always wrong. We always need to take the angle between the ray and the normal. Not any other angle. So these are the two diagrams that we were discussing when we enter from air to glass towards normal, glass to air away from normal. And whenever a light enters at 90 degrees to the surface, this is also an important point that it is parallel to normal, the ray would go undeflected, and these two rays would always be parallel. I guess I have given you these information in the very beginning when I was giving you the introduction to this chapter. You could see here these two rays are parallel to each other. They have the refractive index here. Light changes direction and passing from one medium to another because the speed of light changes. The ratio of speed of light in vacuum to the ratio of speed of light is constant and is called a refractive index. And C has a constant value and value of V. Where you do not need to memorize anything. Everything would be given to you. Okay. This is the point. Since refractive index both are the speed, so it would be a unitless quantity and will always quantities values of an optical medium always greater than or equal to 1 by definition of index of both. Snell's law is basically n1 sine theta 1 is equals to n2 sine theta 2. Snell law is basically given as sine n1 sine theta 1 is equals to n2 sine theta 2. This formula is known as Snell's law. This is used when we are discussing the refraction in two medias. And this is the basics of our next topic that we're going to do, which would be critical angle and total internal reflection. These two topics are based on Snell's law, this is basically N1 would be the refractive index of the force medium, theta is the angle in the force medium, N2 with the refractive index of second medium. बल्कि सब थ्योरी गिवन होगी यहाँ पे ये रहा हाँ ये लिखी हुई है theta angle of incidence is theta 1 in the force medium and 1 is the refractive index of the force medium. For media 2, angle of refraction is theta 2 and n2 is the O. So theta 1, theta 2, n1 and n2. And this is the Snell's law. अब उन्होंने स्नेल्स लॉ के डेरिवेशंस यहाँ पे बेसिकली यहाँ पे साइन थीटा ओवर आर इज इक्वल्स टू एन, वो जो हमने फॉर्मूला किया था ना वहाँ पे अभी जो मैंने आपको ऊपर खुद फॉर्मूला ड्राइव करके दिया, तो इन्होंने बेसिकली वो किया. हाउ डिड वी रीच टू दिस फॉर्मूला? व्हाई वी आर नॉट सीइंग एन हियर? बिकॉज फॉर एयर एन इज ऑलवेज 1. सो इस वजह से ये फॉर्मूला यहाँ से आया. Otherwise, it's if it's not air or कोई less dense medium, more dense medium आता तो उसमें n1 sin theta 1 is equals to n2 sin theta 2. We'll discuss this in detail in the next lecture. Let's review this from the other book. Here the definition of reflection is given. The bending of light as it passes from one transparent medium to another is called reflection. Here we could see that incident angle, reflected angle, incident ray, normal. Again, the law of refraction would have the takriban similar points that incident, normal, and reflected all lie in the same plane. And the ratio of angle of incidence to the angle of reflection is always constant, which is equals to the refractive index. Sine I over sine I. This formula is used when it's entering from air to glass, and the other formula would be used. This is the other formula. The refractive index is basically found out using this formula, which is C over V, speed of light in air over speed of light in that medium. And the next topic is similar that we're going to do in the next lesson. Acha, here's this question, whether the bending of light would be more or less with high refractive index medium. What would be the bending if the media has a high refractive index? Would it be less bending or more bending?
More.
More.
And N has a inverse relationship with sine R. You could see here. Refractive index has the inverse relationship with the speed of light. Similarly, the other formula is sine I over sine R. So if this is bigger, which means speed of light in that medium would be small. और अगर हम उसको रेफर करें साइन आई ओवर साइन आर के रेफरेंस से, तो इफ दिस इज बिगर तो ये हमारे पास क्या होगा? रिफ्लेक्शन वुड बी लेस इन
Okay.
कॉन्टेक्स्ट विद दिस फॉर्मूला. ठीक है. हमने ये पढ़ा भी था ना कि आई और आर का रिलेशनशिप क्या होता है. Okay, that's the end of today's lesson. Let me know if you have any. This is something important in reflection. So you could see here clearly that in reflection, the speed of light changes due to the change in wavelength, but frequency and hence the color does not change. So the wavelength would decrease as compared to the, so you could see here the wavelength is bigger, here the wavelength is smaller. Frequency would remain same, only the speed and wavelength would change according to the equation V is equals to F lambda. Because F would remain, if F is constant, so V is equals to constant into lambda हो जाएगा. I have explained this equation before as well. So, in order to keep frequency constant, if speed and wavelength would change accordingly. Now, I think so that is the final thing that we need to review. Dispersion हमें पता है dispersion of white light क्यों होती है? It is due to the change of media. When all of them are traveling across the same medium, nothing would happen. As soon as the white light enters to some other medium, the white light would disperse into its component color. These Vibgyor हम लोगों ने previous class में भी पढ़ा हुआ. So violet reflects the most, red reflects the less, and going down reflection occurs the most. So at the bottom violet होगा हमेशा and at the top हमेशा कौन सा होगा? Red होगा. ठीक है? You could see here
Okay.
top and red. And जब वो फिर बाहर आएंगे तो obviously it would be the other way around. It's a very good diagram to refer to everything, no? So this spreading or splitting into its component color is this phenomena is known as dispersion, and the colors we get is known as spectrum. And as you go from red to violet, reflection is greatest. This might have been mentioned somewhere as well. So the next topic that we will do today is in response to the last topic that we have done, which was refractive index. We did two formulas, and the diagrams were respectively as this one. So N basically is defined as the uh, N is equals to C over V. Here C was the speed of light in air slash vacuum, and V was the speed in that medium. From that, we discussed about this thing जहाँ पे light reflect करती है, and that is K. Oh, sorry. This was our वो, ये normal था, reflection and normal and away from normal. So incident angle, reflected angle, incident angle and reflected angle. In this context हम लोगों ने ये बात करना था कि away from normal. Basically अगर हम इन रेस को थोड़ा सा आगे ट्रेस बैक सीधा ले जाएं, so we would be able to show कि ये away from normal bend होगा and this would be towards normal. Now, one thing that we need to keep in our mind in respect to this thing is, for this part of the wave, which is from air to glass, the refractive index would be equals to sine I over sine R, whereas incident angle would be greater than refracted angle. For this part of the wave, where it's entering from glass to air, it's going to be sine R over sine I. The thing that we need to do and discuss today is critical angle and Snell's law. Critical angle is that angle of incidence. Critical angle is defined as, we need to be very careful with this one. This is an incident angle, okay? But which incident angle would be called a critical angle? That's what we need to discuss today. An angle of incidence for which the refracted ray makes an angle of 90 degrees with the norm. अभी तक हम लोगों ने क्या पढ़ा था कि ये मेरे पास एक ग्लास ब्लॉक है. Then let's not draw the glass block as well. This is glass boundary. This is incident angle and this is refracted angle. This is we have studied so far. Okay? But there is a certain angle of incidence when that incident angle hits the surface, the refracted ray, instead of going into the medium, it makes an angle of 90 with the normal, like this. This is the surface, glass surface. This is incident angle. This is incident angle. Okay? Instead of going like this, जो normal reflection होती है, critical angle के ऊपर, it would make an angle of 90 with the normal. Let me increase the thickness of it. It would go like this, such that it's making an angle of 90. That angle of incidence for which the refracted ray is making a 90 angle with the normal is known as critical angle. मैं दोबारा समझा दूं. Normally क्या होता है कि ray incident होगा and according to the law वो away from normal चला जाएगा. But there is a certain angle of incidence when at that angle the ray hit the surface, the refracted ray makes an angle of 90. It goes like this, such that it makes an angle of 90 with the surface. This is my normal, and this is my incident ray. This is my reflected ray, and it's making an angle of 90 with the normal. Such incident angle is known as critical angle. Balki an angle would be called a critical angle if the refracted ray is making an angle of 90 with the normal. Clear?
Yes.
Using this fact, we go for the Snell's law, जो हम लोगों ने कल पढ़ा था कि it's medium one, incident refractive index of denser. Just we not say denser or more denser, less denser. Just refractive index of the first medium, angle of incidence in that medium, refractive index of the second medium, and refractive angle into the next medium. Let's say first medium is air and second medium is glass. ठीक है? We say for air we know the refractive index is given as 1.02. Let's start putting the values into this equation. Let me write it down here again. N1 sine theta 1 is equals to N2 sine theta 2. N1 is air and theta 1, sorry, it would be glass, not air. Because हमने total internal reflection discuss करना है इसके respect से. Theta 1 would be critical angle and 2 would be air in which it has to enter, and theta 2 would be the refracted angle. ठीक है? So as we know कि refracted angle क्या बनाएगा? 90 degrees angle बनाएगा when incident angle is equals to critical angle. So when we put the values into this equation, we have n1 or just n, let's write sine theta c. This indicates the critical angle. The value of n for air is 1 and refracted angle is making an angle of 90. So we have n sine theta c is equals to 1 and n is equals to 1 over sine c भी multiple जगहों के ऊपर लिखा हुआ होता है. ठीक है? So using Snell's law जो कि less dense medium to more dense medium में होता है. So using this formula we can find out the critical angle for any medium. हमें अगर उस मीडियम का रिफ्रैक्टिव इंडेक्स पता है, हम बस उसको पुट करेंगे. What will be the formula then? It would be sine c is equals to 1 over n and c is equals to sine inverse 1 over n. We will find the critical angle. So whenever a light is incident at critical angle, refracted ray makes an angle of 90. But if incident angle is greater than critical angle, there would be a phenomena which would be known as total internal reflection. Obviously, when incident angle approaches critical angle, refracted ray makes an angle of what did refractive angle do? It makes an angle of 90. But what if we increase the angle of incidence? So obviously it would go into the medium such that law of reflections would be applicable. This property of light using critical angle is used in optical fibers for communication. Snell's law use किया, सारे concepts put in किए, and we discussed the total internal reflection. ठीक है? Total internal reflection occurs when incident angle is greater than critical angle and the laws of reflections are applicable now. So now, since the light, instead of going into air, it comes back to glass. We use this for communication and optical fibers that we're going to read in the next topic. For now, so you could see in this following diagram that this is the normal thing. Light, incident angle is less than critical angle, light is reflecting. Reflection and reflection साथ साथ चल रहा होता है. This is the point. This shows that incident ray is equals to critical angle. So the refracted ray is making angle 90. Avoid this thing for now. ठीक है? हर जगह पे आपने reflection साथ साथ show कर रही थी. This is the point when incident angle is greater than critical angle, then total internal reflection occur. For total internal reflection, the light must travel from optical more dense medium into an optically less medium. जो हमने n1 sin theta 1 is equals to n2 sin theta 2 किया था ना, उसमें हमने n2 को क्या consider किया था? Air, which was optically less dense medium. For angle of incidence must exceed the critical angle, जो मैंने भी आपको explain किया कि for total internal reflection, it must exceed the critical angles. Then उन्होंने values put किए यहाँ पे. N1 is considered as the denser medium. Critical angle is the theta. And respectively, by putting the value, we reach to a formula which is, I guess आगे example start होगी. It's N2. ये sometimes अगर हमारे पास critically next medium is not air but some other medium, तो फिर we can keep this formula as it is. ठीक है, बाकी सब चीजें वही रहेंगी. N2 over N1 हो जाएगा. If it's air तो यहाँ पे 1 पुट कर देंगे. If it's not तो फिर जो भी values होंगे उसके respectively हम critical angle find out कर लेंगे. हमने उस पर्टिकुलर इक्वेशन के अंदर N1 को N2 को एयर कंसिडर किया था. इफ वी नॉट कंसिडर इट एयर बट हमारे पास कोई और मीडियम है, द फॉर्मूला वुड बी लेफ्ट लाइक दिस. ठीक है, N2 over N1, and they have मतलब discussed this example as well, that refractive index of polystyrene is 1.41, refractive index of water is 1.39. So which one is more critical, more dense medium, polystyrene or water? And उसने एयर के साथ भी दिया हुआ. Anyhow, critical angle find out करना है. N2 would be considered as water and N1 would be considered as polystyrene. हम लोग values put करेंगे. Sin inverse 1.3 over 1 plus critical angle is 1.1 degrees, which means अगर if I will keep this angle 1.12, my light will be totally internally reflected. वो water में enter नहीं होगी. Instead of air यहाँ पे अगर हम water लिखते हैं और glass की जगह polystyrene. सेकेंड उसने कंसिडर करने को बोला एयर को. एयर की वैल्यू इज 1.102 और 1.49, 42 डिग्रीज इज द एंगल. यानी अगर हम एट 42 डिग्रीज एंगल लाइट विल बी इंसिडेंट, so it will get totally internally reflected. This phenomena is used in optical fiber. You must have seen these kind of things. Decorative mediums आप लोगों ने देखे हुए होंगे. This is occurring total internal reflection. This is core and this is cladding. ऑप्टिकल फाइबर्स के अंदर these are the layers, more dense and less dense medium. जैसे जैसे आप अवे जाते हैं from the center तो less dense medium आ रहा होता है. And jacket is basically the protective coating that we give on the optical fiber, because these are basically thin glass strands which uses light as a communication purpose, so they needs to be very carefully used. So as you could see here, optical fiber is an innovative and exciting way in total internal reflection is used to transmit information by light pulses. Optical fiber cable has cylindrical shape. It consists of three concentric section: core, cladding, and the jacket. Innermost layer of the optical consists of very thin strands made of glass or plastic is called core. A material has optical properties different from the core that surrounds and is termed as cladding. Less dense medium जो होता है. So many categories of optical fibers, but जो जितना उन्होंने हमें बताया हम ये बोलेंगे. बाकी उन्होंने बेसिक उसकी प्रॉपर्टीज बताई हैं. We'll go to the next topic, reflection of light. Once your जो dispersion of white light into its component color, वो तो हम लोगों ने पहले ही डिस्कस कर लिया था. तो what is dispersion spectrum क्या होता है basically when the media for the light white light changes? So we have a spectrum of color which is known as we have this phenomena which we have dispersion, and हमारे पास जो है अब लेंस सॉरी जो प्रिज्म इज अगेन अ ग्लास. हमारे पास जो है ग्लास मीडियम होता है. सो व्हेन द लाइट एंटर्स इनटू दिस मीडियम, they have equal speeds in air but they have different speeds in prism. So when light enters into this medium, it gets reflected in the same similar pattern as they do in uh, the glass block. एंगल ऑफ डेविएशन है, यू कैन सी के वही उन्होंने पॉइंट डिस्कस किया हुआ है कि अगर if this light would have gone straight like this and this light would have gone straight like this, so this change is known as angle of deviation. Rest I have already explained to you. So in the prism figure shown in 12.3, the incident ray of light travels through air and enters into the left side of the glass, this glass prism left side. The light bends towards, towards the normal in the glass because of glass having higher index of reflection, so speed would decrease in the medium. When light leaves the glass into the air on the right side of the prism, the light is reflected away from the normal because the direction of light leaving the glass is different from that light entering into it. Cause यहाँ से air to glass जा रहा है and from here glass to air जा रहा है. So उसने वही चीज repeat की है. The change in direction of light as it passes through the glass is called its deviation, and the measure of angle as deviation angle, which is theta. Dispersion of white light. Dispersion of white light हमने पहले discuss किया. It occurs because of the change of the media. So when white light falls onto a prism, it's split into its component color called spectrum that I've just explained to you before. The effect is termed as dispersion of light. So this is known as dispersion of light, and this is called spectrum. Okay, this component colors is known as spectrum. We have red on top and violet at the bottom, or if we go the other way around, it's like this. It reflects the most, reflects the most, violet reflects the most, and red reflects the least. उन्होंने लिखा भी होगा. It arises because the white light is a mixture of wavelength and interacts differently with glass. As long as they're in air, they would have the same values. As soon as they enter the glass, they would have different values. The prism separates the color because the refractive index of the glass is different for each color. It is greatest for violet and smallest for red light. We would start the lens topic in the next lesson, and the lens equation and everything is exactly the same that we have studied so far. So yes, that's it for today. So the next topic in light is lenses. Lenses are basically transparent mediums in which we study the properties of refraction in particular. So lenses are transparent mediums, mostly of glass, in which we study the properties of refraction in particular. There are two types of lenses, and they are convex lens, thinner at the edges and thicker at the center. Similarly, concave lens, which is thicker at the edges and thinner at the center. The same thing, जिस हम लोगों ने मिरर्स के अंदर पढ़ा था, radius of curvature, center of the lens, and distance from center of the lens to the वो जो है a line passing through the radius and the center of the lens is known as principal axis. That goes for both of it. इसके अंदर आपने this line is important, the vertical axis. After this lines, the difference comes to convex and concave. For convex lens, after passing through this line, the light converges to a point. That is why convex lens is also known as converging lens. ये दिखा हुआ है. They meet at a point, and after passing through this line in a concave lens, the light spreads out. So the major difference between convex and concave lens is that after, let me try to make a neat diagram. Okay, if this is convex lens, and this is also known as converging lens, and this is concave lens, also known as diverging lens. Why do we call it converging and diverging? As the name indicates. Okay, once the light, this is the vertical axis, center of these lenses. Okay, so whenever the light passes through these centers से जो जाएगी, it goes undeflected, and other sides में जाएगी, they will converge to a point. So this point at which the light converge is known as the focus point, and
Chemistry or math means
and this, after passing through the concave lens, the light diverges. Again, the line with ray lighted, which is passing through the center, it goes undeflected. And this is like this. So that is the diverging lens. So here we could see the rays of light are actually meeting to this point. मुझे ना एक सेकंड इसकी थिकनेस थोड़ी कम करनी. Okay. So we could see the light is actually meeting here. So it means que the light is converging. Sorry, this focus point is actually real. And we need to trace these points back here. So इसको virtually बना भी देता हूँ मैं. We trace these points back and they meet this point. So since we traced back these points, बल्कि मैं इसे यहाँ पे लिखता हूँ. ये भी focus है, but this is a virtual focus point. ठीक है? This is a real focus point. Why are we calling it real? Because the ray of light is actually meeting here. But ray of light are not actually, we have traced this back. So the light after passing through concave lens diverges like this, and the light after passing the lens, it converges to a point. So both of these points at which the light meets after passing through the lens is known as focus point. This is the center of the lens. This is the focus point, and the line which passes through the center of the lens and the focus point is known as principal axis. यहाँ तक clear है हम लोग? Do you have any
Yes.
questions up till here?
No.
Okay. Moving on, you could see the diagrams in कुछ तरीके से देख लेना कि how to draw a convex and concave lens. This is the property that the concave and convex lens shows here. After passing through the lens, they meet to a point. This is and this diverges to this point. So you could see here, okay, these rays of light are meeting. We trace these points back to meet at a point. So this is a virtual point, focus point, and this is the real point. And reflection is occurring through it. Reflection exactly उसी पैटर्न पे होगी जो हम ऊपर पढ़ के आए हैं. ये देखें, reflect towards medium, away medium, towards medium, away medium. Cause उसने rate हमारे पास यहाँ पे क्या था? Air, and this was glass. So the refractive properties would go as we have discussed in the previous lesson. Okay. Focus point उन्होंने यहाँ पे शो किया हुआ है. Focus point is same on either side. So अगर ये lens है हमारे पास, this is the focus point which is 2 centimeter from the lens. तो यहाँ से भी 2 centimeter होगा. Next focus point किस पे आके बनेगा? 4 centimeter पे. यहाँ पे भी 4 centimeter पे आके बनेगा. So focus points, this would be known as F, and F, this would be 2F, and 2F similarly. Next focus point कितने centimeter पे आके बनेगा?
6.
Lemma, next,
6,
yes, and then 6, this would be called 3F, 3F and so forth. Focus point का काम क्या है? We will study that जब हम lens को further on detail में पढ़ेंगे. This is written right here, center of the lens and everything. कुछ major points हमने यहाँ पे discuss किए हैं जो लेंस और उसके बारे में हैं. अच्छा, रियल एंड वर्चुअल इमेजेस के बारे में बात होगी, बट कीप दिस इन माइंड. जैसे हम लोगों ने मिरर्स के केस में पढ़ा था ना, द रियल एंड द वर्चुअल पॉइंट इज डिसाइडेड on the distance of the object from the mirror. Similarly, it goes same for the lens as well. The real and the virtual image. Normally, convex lens make real images, and जो concave lens and they made virtual images. What is the meaning of real and virtual image? We're going to go in detail regarding वो हम लोग उसको डिस्कस कर लेते हैं. पहले वर्चुअल एंड रियल इमेज का मीनिंग क्या होता है. वर्चुअल इमेज जो है हमारे पास and real image. We are discussing this in context to lenses. ठीक हो गया? So, virtual image is the one which is formed on the same side of the lens or object. Same side of the object would be more appropriate. I would show the diagrams as well कि कैसे होता है वो, ठीक है? This would be opposite, which is formed on the other side of the lens. Second point है हमारा virtual images would be upright and real images would be inverted. Now let's say what a virtual and real image would look like. For example, this is the lens, this is the principal axis, this is the vertical axis, of this is the focus point on either side, of this is the object. We need to keep this in mind, though it's not something that you need to memorize in Federal Board, but still, there are three types of rays that we discussed for the lenses. One, which is parallel to principal axis, passes through the focus, थोड़ा सा outside चला गया, passes through the focus, and the ray of light which passes through the center goes undeflected. So the rays which meets object is here, images formed here where these light rays would actually, जब हम up to scale बनाएंगे ना, they would meet. The one which is passing through the center, it goes undeflected. The one is which is parallel to principal axis passes through the focus. Are we clear about these two types of rays? It would stay common in all the lenses. Again, I repeat one more time. This is the principal axis. Okay. This is my object. So the ray of light which is parallel to principal axis, it would pass through the focus. The ray of light which passes through the center of the lens goes undeflected. So the point at which they meet, where they meet, the image would be formed like this. And you could see here, the image is inverted. Object is placed like this, image is inverted. So this is an indication of a real image. Secondly, object is on this side of the lens, the image is formed on the other side of the lens. This is also an indication of real image. But the size of the image would totally depend on the distance from the focus point. I'm not showing the second focus or the third focus, the first focus point. As you are further away from the focus point, image formed would be smaller. As you approaches the focus point, image formed would be enlarged, magnified. But the moment you enter the focus point, when you are inside the focus point, the image formed would be virtual and upright and mostly magnified. When will be the virtual image will be formed?
When you enter the focus point.
When we are inside the focus. For example, they have told us in the question that the focal length is 6 centimeter and the object is placed at 2 centimeter. So does it mean it's inside the focus or outside the focus?
Inside.
Okay. So if the focus point is 6 centimeter and the object distance, which is P, is placed at 2 centimeter from the center of the lens, so image formed would be virtual. But if the object is placed at 10 centimeter, image formed would be real. And two चीजें क्या common होंगी? Real and inverted. Magnified होगा, magnified means enlarged होगा कि नहीं, वो depend करेगा distance from the focus पे. If it's closer to focus point, image will surely be magnified. और enlarged का word use करेंगे हम लोग. But if it's away from the focus point, image would be smaller. So we can write it as closer to focus. क्या होंगी image property? Real, inverted and magnified. And अगर हम लोग away from the focus होंगे, image क्या होगा? Real, inverted and smaller. Is the sun that small that we मतलब जिस तरह हमें वो दिखता है क्या वो वाकई इतना छोटा है सन और मून?
No.
No, they are not. ठीक है? Why they appear smaller than their actual sizes? Because they are much further away from us. And which lens do we have in our eyes? हमारी eyes के अंदर कौन सा lens लगा हुआ है naturally? Do you guys have any idea?
I don't know.
Biology में होगा पढ़ा हुआ.
I don't take biology.
Oh,
We have not
no.
studied that portion.
अच्छा फिर convex. We have convex lens in our eyes naturally. ठीक है? So image जो हमारे अंदर form होता है डबल कन्वेक्स लेंसेज लगे हुए होते हैं. दैट इज वाई हम अपने जो सामने खड़ा हुआ बंदा है उसको हम लोग जो है उल्टा नहीं देख रहे होते, वो सीधा ही दिख रहा होता है. सिमिलरली जो कैमरा लेंसेज होते हैं उसके अंदर भी कन्वेक्स लेंस लगते हैं. So are we clear about the lens and their properties and the real and the virtual images and how they are formed?
Yes.
Yes.
अच्छा एक और कॉमन चीज है which you must memorize और keep this in your mind. The parallel rays, उनका क्या एक रोल होता है. So you could say here, you could see कि ये parallel rays हैं सारी की सारी और after passing through the lens they converge to a point. Similarly अगर कोई converging rays आएंगी towards the lens, ठीक है, they would become parallel, opposite होगा उसका. I repeat कि अगर parallel rays आ रही हैं they would converge or diverge after passing through the lens. But if already converging or diverging lines are coming towards the lens, they would become parallel. ठीक है? There might be a question
Okay.
into that. बाकी मैग्निफिकेशन है. मैग्निफिकेशन का एग्जैक्टली वही मीनिंग है जो हमने मिरर के अंदर पढ़ा था. एंड 1/f इज इक्वल्स टू 1/d प्लस 1/, मतलब 1/p/1/q कर लें और 1/, डिस्टेंस ऑफ इमेज और डिस्टेंस ऑफ ऑब्जेक्ट कर लें. वर्चुअल एंड रियल का एग्जैक्ट मीनिंग वही रहेगा. डेरिवेशन ऑफ इक्वेशन एग्जैक्टली द सेम दैट वी हैव डन इन द प्रीवियस लेसन. उन्होंने दो ट्रायंगल्स को आपस में ये यू कुड सी हियर द पासिंग थ्रू द लेंस गोज अनडिफ्लेक्टेड, parallel to principal axis, passes through the focus. So the point at which they meet, we draw the image. So we have height of image, height of object, distance of image, distance of object, and distance of image. Never confuse this distance with this distance. This is the distance of image. This is the focus point. हमने इसको मिक्स अप आपस में नहीं करना. डेरिवेशन ऑफ इक्वेशंस एग्जैक्टली उन्हीं बेसिस के ऊपर है जो हम लोगों ने पहले की थी. ये हमारे पास एक ट्रायंगल ये है, एक ट्रायंगल ये है. अकॉर्डिंग टू द रूल्स हमने जो पीछे डेरिवेशन किया था फॉर मिरर, एग्जैक्ट वही डेरिवेशन है. एंड वी हैव रीच्ड टू दिस इक्वेशंस. बाकी जो प्रॉपर्टीज ऑफ कन्वेक्स एंड कन्वेक्स लेंस. अच्छा फोकस पावर ऑफ द लेंस इज इनवर्स ऑफ द फोकल लेंथ, बस हमने याद रखना है. और दिस इज एन इम्पोर्टेंट. डायोप्टर में उसकी वैल्यू होती है, यूनिट्स यहाँ लिखा भी होगा. हाँ इट्स राइट हियर. यस, लेट मी वॉक यू थ्रू द टेबल. Convex lens focal length is positive and negative. Positive means real, negative means virtual. Object is on the left side of the object if object is on the right side of the lens. I have explained all these points. You can go ahead and read it on your own. यूज में आते हैं उसके अंदर. जो थिक लेंस होता है दे हैव स्मॉलर फोकस पॉइंट्स और फोकल लेंस. और जो थिक लेंस होता है, थिन लेंस होता है, इट हैज अ बिगर फोकल लेंस. सो यूजिंग दीज जो है डिफरेंस ऑफ फोकल लेंस ऑफ द थिक एंड द थिन कन्वर्जिंग लेंसेस और डाइवर्जिंग लेंसेस वी टेक इनटू अकाउंट फॉर द यूज इनटू माइक्रोस्कोप्स and telescopes. So
Okay.
I repeat that there are two types of lenses: thin converging lenses and thick converging lens. The one which are thick in size have smaller focal length, and thin lenses has larger focal length. We take into account in that. और जो microscope होता है उसमें we use lenses with small focal lengths and object is placed inside F to visualize a magnified image of the object. Power of the lens की definition is very important. It is a reciprocal of the focal length and the unit is given as diopter. कैमरा लेंस के अंदर मैंने आपको ऑलरेडी पहले बता दिया था, दे यूजेस कन्वर्जिंग लेंस एंड दे मोस्टली मेक अच्छा मुझे बताओ, if we are not seeing the inverted image of something, does this mean it's a real image or a virtual image? For converging lens.
It's virtual.
Yes. Real and virtual could easily be identified using just seeing that whether they're upright or inverted. ये वो पॉइंट्स हैं छोटे छोटे जो मैंने आपको जो थे उसमें बता दिए थे. आई थिंक सो यू कैन नॉट सी द स्क्रीन. शिट, कैन यू सी द स्क्रीन नाउ? You could have told me that my screen is not shared.
It was shared.
This is
Oh, okay.
I wrote everything down, but I think so we missed it. Anyhow, the small and वो जो bigger focal lens की एक virtual diagram भी बना के दे देता हूँ. If the lens is thin, its focal length would be larger. This is the axis. It would have a larger focus point. And the one which is thick, it would have a smaller focal length. This property is used in different apparatuses and so, जिसको हम लोग उसके अंदर यूज भी करते हैं. कैमरा उन्होंने आपको दिखाया हुआ है. Here we have a lens, a mirror to reflect the light. Then we have a prism or so. You could see here कि 45 degrees के ऊपर bend हो रही हैं and images are being formed. तो ये यहाँ पे लिखा है ना, when the button on the camera is pressed, the mirror flips out of the way, the shutter opens to allow light falls onto photographic film and starts a chemical reaction as shown. Light rays here. Light rays from a point of an object being photographed must be converged to a corresponding point on the film. Photographic film consists of a thin sheet of plastic coated with tiny silver crystals in gelatin. The crystals react to ये पुराने cameras की बात हो जिसमें photographic films ऐड होती थी. You might have seen that in the movies as well. Negatives होते थे, हम उनको फिर डेवलप करवाते थे. ये उन lenses के बारे में बात हो रही है कि उसके अंदर. और प्रैक्टिकल लेंस के अंदर if you examine any pair of eyeglasses you will discover both surfaces curved in the same direction. One side is convex but the other side is concave. But how can you classify such lenses? हमारे पास types of lenses भी होते हैं which are double convex lens, planar convex lens and converging meniscus, diverging meniscus. These हैं, although आपको इनकी working principles as it is याद नहीं करने हैं. Magnification power वही height of image over height of object, और angular size of final image produced by an optical instrument divided by reference angular size of object seen without any optical. बीटा over अल्फा का एक फॉर्मूला यूज होता है, थीटा उन्होंने यहाँ यूज किए हुए हैं. Let me take you to the other book. There might be some good images and theory over there. हमने endoscoping and total internal reflection in optical fiber की uses पढ़ लिए with an angle of deviations and everything.
Yes, I think.
Here we have all the definitions that we need. The focal length is the distance between the optical center and the principal axis. Principal focus where all of the light converges to a point or diverges to a point. अगर वो concave lens है तो diverge होंगी.
You're muted.
Oh, I'm so sorry. Can you see the screen at least?
Yes.
Yes.
Okay. Thank you for notifying earlier. I don't know the first part was even recorded or not. The topic that we're going to discuss today is the magnifying power. Sorry, we'll resume from the magnifying power and the resolving power. Magnification, basically, we have discussed in the mirrors as well. It is the difference in the height of the image or when it's formed. So lenses के case में magnification is only then when it is placed inside the focal length. So whenever object is placed inside the focal length, the image formed is virtual, enlarged, and on the same side of the object. So whenever we discuss the magnification power, it is basically the angle subtended on the eye with the optical instrument divided by angle subtended without any instrument on the naked eye भी कह सकते हैं or without any instrument. So अगर if there is some lens placed और यहाँ पे आया है हमारे पास and angle subtend हो रहा है हमारे पास like this is the वो तो ये with the help of this ये numerator पे आ जाएगा and without any जो यहाँ पे object है हमारे पास और image form हो रहा है हमारे पास somewhere हाँ यहाँ पे and जो हमारे पास angle subtend होगा without any instrument placed तो उन दोनों को डिवाइड करेंगे विल हैव द मैग्निफिकेशन पावर और मैग्नीफाइंग पावर जो resolving power है that is basically how can we distinguish between two different objects how far they are normally जैसे मैंने यहाँ पे figure out किया हुआ है कि it seems like there is only one thing coming over here ठीक है अब एक larger distance के ऊपर but as soon as it come closer to it we see that it's basically two light sources so resolving power basically help us to identify two different objects distinctly. Do you get the meaning what resolving power is? Okay, from the far away, it seems like this source is, there is only one source of light coming here. But as soon as it start coming closer, we would see that it is basically two light sources which are approaching us. बेशक वो एक ही कार के headlights are different, but resolving power helps us to distinguish between two objects clearly. Whereas magnifying power is the ratio of the angle suspended on the eye using an optical instrument divided by the naked eye. And resolving power is the one through which you can easily identify the difference between the two objects that are close together and produce distinct images of the two objects. Definitions are very important. Do you get the meaning of resolving power? Example उन्होंने साथ में दे दी, it's very good. ठीक है? यहाँ पे उन्होंने I guess they have discussed this, the example as well. ठीक है? And simple resolving power varies inversely with the distance between the two objects to be resolved when viewed from an optical instrument. Thus, the image of two close lying objects should appear जितना ज़्यादा distinctly उनको वो करते हैं मतलब उसको जितना भी close put कर दें but still it helps sorry दूर put कर दें तो it helps us to identify कि जी two different objects and that is what resolving power is basically. Consider telescope is used to view two stars placed closely. The telescope resolving power will depend on its ability to resolve the images of the two stars. Sorry. Image formation basically हमारे पास हम लोगों ने कल भी discuss किया था in the previous lesson that we have convex lens in eye naturally और हमारे पास retina के ऊपर जब वो meet करती है तो हमारे पास light बनती है तो normally जो normal eye होता है it could clearly see an image placed within 25 centimeter a distance from the eye वो clearly एक image दे सकता है healthy eye with the passage of time or with some issues there are two types of eyesight issues that we call short-sightedness and long-sightedness. Short-sightedness that we cannot see the distant objects clearly and long-sightedness that is we cannot see the closer object distinctly. So why this occur? This basically occurs when the images are being formed behind the retina or before the retina. Okay? As you could see the image of the eye here, that we will see the image when it will be formed on the retina. If it's not being formed on the retina or somewhere before retina or behind retina, this will be called short sightedness and long sightedness. जो behind retina जाके बनता है हमारे पास, this like this, वो short sight long sightedness होता है, और जो before retina बनता है that is short sightedness. Short sightedness is corrected using concave lens, or short sightedness is used long sightedness is corrected using convex lens. अब ये देखो, this is the image that the object is forming behind the retina, which I was telling you. ठीक है? But by using a convex lens, plano-convex lens this time पे use किया हुआ है उसने, so we make the image on the retina. You only need to memorize this and these diagrams. You would not have to be an art student. Just make sure that you show that normally the image is being formed behind the retina, and using the correction of convex lens, the image is formed on the retina. Long-sightedness definition दी हुई है is the defect in human eye in which it can only focus on distant objects, so nearby objects are not clearly seen. This defect is also called, I don't know how to pronounce it, but hyperopia something, I don't know. And later on उन्होंने वहाँ पे जो है वो उसको discuss किया. Whereas short sightedness के अंदर image is formed before retina, and this is corrected using a which lens? Plano-concave lens. Corrected. अब you could see here divergence हो रही है यहाँ पे, ठीक है? ये हमारे पास लाइट सोर्स आया, लेंस में से पास हुआ, it diverged. जब concave में enter हुआ, it converged again. You could see here divergent and convergent. Because this one fitted in the eye is the convex lens. Similarly, if I take you here, you could see here it converged and then converged again. And then converged again. Very slight, sir. बहुत slight सी हो रही है. But basically, we know the properties of concave and convex lens and how they refract the light when it passed through it. So, are we clear about long-sightedness and short-sightedness?
Yes.
And that 25 centimeter distance जो है ना, उसको कहते हैं least distance of distinct vision. They might have mentioned that here as well. They have normal human eye जो है ना, it could focus the image within the 25 centimeter range, and that distance is known as least distance of distinct vision. 25 centimeter is the least distance of distinct vision. Okay? और यहाँ पे उन्होंने बताया हुआ कि accommodation is basically the process of adjusting the eye's focal length is called the accommodation, जो कि हम करते हैं with the help of concave and convex lens. वो least distance में नहीं है रहा. The shortest distance at which an eye can form a sharp image of an object is called the near point of the eye, or least distance of distinct vision. Normally, it's 25 centimeter for youngers, and it increases with the age, leading to short-sightedness and long-sightedness. Angles formed ये naked eye के साथ. Here you could see this is the angle formed with the help of the naked eye, and this is the angle formed with the help of some optical instrument. So this angle divided by this angle is the magnifying power, जो माइक्रोस्कोप में बेसिकली यूज होती है. यू कैन सी हियर माइक्रोस्कोप की मैंने एग्जांपल आपको वहां पे भी दी थी मैग्निफिकेशन के अंदर, तो उन्होंने बिल्कुल पहला एग्जांपल वही डिस्कस किया. वुड द इमेज फॉर्म वुड बी वर्चुअल और रियल? What would be the property of
Virtual.
the image? And why is that? Because it's placed within the focal length of the object. Here you could see passing through the center goes undeflected and parallel to principal axis passes through the focus point, and I उसको trace back करेंगे and image form will be like this. This is the object, this is the image. So this angle versus this angle is the magnifying power of the simple microscope. Simple microscope basically हमारे पास एक simple convex lens ही होता है और जिसकी inside the focal length हम object को place करते हैं to get the, यहाँ पे distance को भी हम use कर सकते हैं, distance of image over distance of object as well, as you could see here as well. मैंने यहाँ पे दिया भी हुआ है and and the angular magnification microscope, when the eye is focused at its near point is 25 centimeter and the lens is the near eye is magnification power is equals to n over f plus 1. उसके नाम near point को add कर देते हैं उसकी value को, और तो further on इसके अंदर कुछ भी नहीं है. दो formulas हैं कि जब object at infinity placed होता है we use n over f with where f is the focal length, ठीक है, and if we place at the 25 centimeter distance, so we use a formula n over f plus 1. Let's review the same topic from our other book as well and see if there is anything else given in that book. It's exactly the same. Resolving power को एक दफा यहाँ पे discuss हुआ है with distributing two closely placed objects or point sources. बाकी formulas वही हैं. The commission magnifying power is given by the relationship 1 plus d over f, where d is the distance of the object. उन्होंने यहाँ पे show भी किया होगा. And f is the focal length. Exact same diagram. Least distance of distinct Vn. And अब this is from the other book और यहाँ पे इन्होंने वो diagrams obviously they are better drawn. So you could see here parallel to principal axis passes through the focus, passes through the center, goes undeflected. And what was the third type of ray जो हमारे पास that passes through the focus point, becomes parallel to principal axis and image formed is like this. Same goes for the concave lens as well. Parallel to principal axis passes through the focus, क्योंकि virtually pass out करना है वही रहेगा, जो center से pass out होगा it goes undeflected, and जो parallel to principal axis ये देख सकते हैं आप, third type of ray parallel to principal axis, और ये the meet at a point जहाँ पे इनको trace back किया हुआ becomes parallel. ये इसका focus point है. अगर मैं आपको मज़ीद if I could, here you could see ये green ray कौन सी थी, parallel to principal axis passes through the focus, ये देखो focus से pass out हो रही है trace back होके. Second type of ray that passes through the center goes undeflected. Third type of ray that passes through the focus becomes parallel to principal axis, उसको ये देखो trace back किया हुआ. So there they meet and image is formed, virtual image हमारे पास. ठीक है, convex lens के images यहाँ पे वो outside and inside focal length वही बात discuss हुई है कि as we approaches the focus point हमारा image bigger होता रहता है. See here, beyond 2f पड़ा हुआ image formed as smaller, when at 2f image is मतलब formed as bigger, and when it's even become closer image becomes greater and greater, and when it's placed at focus point no image is formed because rays meet नहीं करेंगी. When inside focus वो हम लोगों ने discuss किया हुआ है. If you guys want to memorize this, तो within 2 f and 2f होगा तो beyond 2f image बनेगा, at 2f होगा तो at 2f image बनेगा, outside 2f होगा तो between f and 2f image बनेगा. It's exactly this image A जब it's beyond 2f तो between f and 2f image बन रहा है, when it's between f and 2f तो beyond 2f image बन रहा है. If ये एक दो दफा देखोगे, you guys will memorize it. So if there comes a question where they have asked where the image would be formed, would it be beyond 2f, within f and 2f, would the image be formed or not? Image किस case में form नहीं होगा lemma? Which is the case in which the image will not be formed?
When the rays meet at the
When the object is placed at the focus point, only then the image will
Oh,
not be formed.
okay.
In other cases, image हमारे पास form होगा. Image locations के बारे में बात हो रही है. लेंस इक्वेशन हम लोगों ने कल ही पढ़ लिया था, 1/f + 1/q. कल हमने इन पॉइंट्स को डिस्कस कर लिया था कि फोकल लेंथ जो है हमारे पास पॉजिटिव कब होगी फॉर कन्वर्जिंग लेंस, एंड फॉर डाइवर्जिंग लेंस इट्स नेगेटिव. क्यों वाई इट्स पॉजिटिव एंड नेगेटिव कल भी हमने डिस्कस किया था कि because rays are actually meeting in case of converging lens, and diverging lens के केस में हमें rays को trace back करना होता है, that's why उसका negative, and वो virtually उसकी basis पे P is positive if the object is towards the left side of the lens, and P is negative if the object is on the right side of the lens. Towards right and left ka meaning, do I need to explain that? Do you guys get it? Okay.
I
If
get it.
this is the lens principal axis, if object is placed to the left of lens, image would be positive. Sorry, object would be positive. It's placed to the right, it would be negative. So this is the left placement, this is the right placement, and the opposite goes for the image formation. It would be positive when it's placed on the when it's formed on the right hand side, and negative when it's formed on the same side of the object. Then we have an example. You guys could review it on your own. It's totally depending upon the वो कैमरा का हम लोगों ने कल डिस्कस कर लिया हुआ था कि हाउ कैमरा इमेजेस आर फॉर्म्ड. मैंने आपको बताया था उसमें कन्वेक्स लेंस ही यूज होता है हमारे पास. Exactly the same. Passes through the center, parallel to principal axis, passes through the focus, और हमारे पास जो images formed हो रहे हैं, images are real, और हम उसके बाद उसकी वो फॉर्म हो जाता है. जो प्रोजेक्टर्स होते हैं उसमें भी रियल इमेजेस फॉर्म्ड होते हैं, एंड कन्वेक्स लेंस हमारे पास प्लेनो कन्वेक्स लेंस यूज हुए हुए हैं. इफ यू गैस रिमेंबर, मैंने आपको कल बताया था कि कन्वर्जिंग रेज फॉल आउट करेंगी तो इट विल बिकम पैरेलल. रिमेंबर कल के लेसन में मैंने आपको बताया था इन द प्रीवियस कि इफ रेज कन्वर्जिंग रेज आर प्लेस्ड ऑन इट तो हमारे पास जो है वो इट बिकम पैरेलल. फिर कन्वेक्स लेंस से पास आउट होंगी तो ये. अब ये हमारे पास लाइट सोर्स है, कनकेव लेंस से जो है रिफ्लेक्ट होके ये यहाँ पे आ रही है हमारे पास, रिफ्लेक्ट आई है डाइवर्ज होके. ठीक है.
Okay.
And the image would be formed, illuminated. ये उसने लिखा हुआ जो मैंने आपको पॉइंट अभी बताया था कि the image provides a real, large and inverted image. It must be real to be projected on the screen. The slide must be placed between f and 2f of the projection lens so as to produce a real, inverted and large image. Cause हमने अभी भी उसको डिस्कस भी किया है. बाकी फोटोग्राफिक फिल्म को यू स्टडी ऑन योर ओन. सिंपल माइक्रोस्कोप पर उन्होंने डिस्कस किया हुआ, ये मैंने अभी आपको रिवाइज करवाया है. मैग्निफिकेशन एंड रिजॉल्विंग पावर. Let me know if you have any questions from here. Here I see some good definitions. Accommodation तो हम लोगों ने कर लिया था ना कि what accommodation is. The variation of focal length of the eye lens to form a sharp image on retina is called accommodation. Near point and far point. The near point of the eye is the minimum distance of an object from the eye at which it produces a sharp image of the retina. उसका opposite जो है वो ये होगा far point, maximum distance of the object from the eye on which full relaxed eye can focus, and defect inability to see the image of the object clearly is called defect of the vision. nearsightedness को जो है वो मायोपिया कहते हैं, लॉन्ग साइडनेस को हाइपरोपिया, जो हम लोगों ने अभी पढ़ा भी था हाइपरमेट्रोपिया. फार साइटेडनेस लॉन्ग साइडनेस बेसिकली, एंड शॉर्ट साइटेडनेस इज नियर साइटेडनेस. सो उसमें कंफ्यूज होने की जरूरत नहीं है, इट्स द सेम थिंग. Here you could see के हो जा फोकस. Images formed before retina. So using concave lens, images being formed on the retina. Same for long sightedness जो है convex lens को use करते हैं. Images formed beyond retina और at retina हमने image को form करना. यहाँ पे उसने बोला हुआ कि thin film can be placed on the lens of the eyeglass to keep them from reflecting wavelength of light that highly visible to human eye. This prevents the glare of the reflected eye. If you use the optical lenses, you must know कि अगर हमारे scratches आ जाते हैं आई glasses के ऊपर तो हमारे पास image भी blurry form होना start हो जाता है again. And the reason behind that is again कि light जो है वो deflect बहुत ज़्यादा हो रही होती है. So we are left with only two topics, that is compound microscope and telescope. That will be done soon. मैग्नीफाइंग ग्लास की एग्जांपल्स भी हम लोग कल ही डिस्कस कर लेंगे. माइक्रोस्कोप्स एंड टेलीस्कोप्स, दैट वुड बी द एंड ऑफ दिस चैप्टर.
So let me walk you through that topic. I've told you before that basically telescopes and compound microscopes have more than one lenses, mostly convex lens, of different focal lengths that we use to make the images large or whatsoever we need anything to be in view so much. We know that convex lens can only form the enlarged image if it's within the focal length or somewhere close to the focal length. And we have studied that in the simple microscope that the enlarged image is formed. Simple microscope, I told you, it's basically a magnifying glass. Okay? Magnifying glass is a convex lens in which the object is placed within the focal length of that object. So in the next two topics that will put an end to this chapter, we have two lenses of different focal lengths that is used to make. You must have seen that in the laboratories as well. In biolabs, normally we have these to view and enlarge the image that is under observation. Here, let me walk you through the diagram. We basically need to see. Let's see the definition first. You guys could see the screen and my voice is clear to you, right?
Yes.
Okay. Compound microscope is a microscope that uses multiple lenses to enlarge the image of a sample that I've just told you. Typically, a compound microscope is used for viewing samples at high magnification, 400 to 1000 times, which is achieved by combined effect of two sets of lenses, the eyepiece, which is closer to the eye, and the object lens, which is closer to the object clearly. Okay? Here is, you could see the focal length mentioned here. This is the focal length of here. This is the focal length of this lens, and this is the focal length of this lens. Whence, let me magnify the image to this one. Okay. Let me take you to the other book. उसमें diagrams proper बने हुए हैं. And उसमें उन्होंने ये diamond shape नहीं बना के दिया हुआ. They basically have shown an arrow which is very easy to understand because उसकी images बहुत easily build up हो जाते हैं. Okay. Can you see the image clearly now?
Yes.
Okay. Here you could see we have two lenses. Object is placed within the focal length of the first lens. Sorry, outside the focal length of the जो है उसको क्या था objective lens, ठीक है? And here it's outside the focus but it's closer to the focal length, so we know okay the image formed would be passing through the focus and center. This is the image formed by the objective lens. Now this image formed by the objective lens would act as an object for the eyepiece lens. Here we could see the image is the object is placed inside the focal length of the eyepiece lens. Again, the same thing is occurring. The rays which are here, you could see these are the rays. Now this image formed by the objective lens is the object for the eyepiece lens, and it's placed inside the focal length of the eyepiece lens. We have an enlarged and magnified image. Basically उन लोगों ने यहाँ पे जो इस ऑब्जेक्ट के साथ ही उनको जो है वो बनाया हुआ है, ये यहाँ पे, एंड इनको ट्रेस बैक किया हुआ है रेस को बैक टू दिस पॉइंट। ठीक है, कन्वेक्स लेंस है, यहाँ से इससे पास आउट हो रही है, एंड हियर इज द images formed like this. So the formula that they use to find out the magnification formed by the क्या कहते हैं, compound microscope is L over F naught into F naught, F O भी कह सकते हैं, it's the focal length of the objective lens, plus into 1 plus D over FE. यहाँ पे उन्होंने सब चीज़ों को mention out किया। D is basically the distance from the eye to the final image formed, and L is the distance of the object from the eyepiece lens. If we know all the values to this, we could easily find out the calculate the magnification of that particular image. If we go to the telescope again, here telescope basically हमें पता है हम लोग distant subjects को view करने के लिए use करते हैं। ठीक है, we have this basic concept कि उसकी जो है focal length जो है objective lens की focal length, and यहाँ पे जो lenses again ये distant subject से lights आ रही हैं, दे मीट एट अ पॉइंट। अब ये आई पीस के इनसाइड जो है वो फोकल लेंथ, यहाँ पे आप देख सकते हो क्लियरली कि ये एफ ओ इज द focal length of the objective lens, which is very large as compared to the focal length of the eyepiece lens, which is small. तो inside ये कोई distant object से light आ रही है, तो now again वही exact the same thing कि the image formed by the objective lens acts as an object for the eyepiece, and the image formed is like this. Again वही बात हो रही है कि convex lens के ऊपर जो है हमारे पास क्या कहते हैं, after passing through the convex lens converges to a point, और जब converging rays जाती हैं they become parallel to each other. You could see here, उन्होंने यहाँ पे उसी चीज को रिफ्रेश किया। आई रिमेम्बर कि हम लोगों ने लास्ट लेसन में भी बात किया था कि अगर जो है कन्वर्जिंग रेज हमारे पास आती हैं दे बिकम पैरेलल आफ्टर पासिंग थ्रू द लेंस। आप उनको जब ट्रेस बैक करोगे तो इमेज फ्रॉम अगेन यहाँ पे। अब अगेन यहाँ पे focal length of this, focal length of eyepiece. Now if we look into the formula for the telescope, the magnification is given as M is equals to F over FE. The only thing that you need to understand in these diagrams is how to draw these diagrams, the proper angles, the distances mentioned, the images mentioned, and everything. There is not much to do in these kind of long questions. Again, telescope का एक basic theory उन्होंने यहाँ पे दिया हुआ है. The here the ray diagram of the refracting telescope is shown in figure this. When a parallel rays from a point on a distant object passes through the objective lens, a real image is formed. We know when object is placed outside the focal length and real image is formed, the real image is always inverted and on the other side of the lens. Real images I1 is formed at the focus of the objective lens. This image acts as an object for the eyepiece. A virtual enlarged image I2 of I1 is formed by the eyepiece at a larger distance from the objective lens. This virtual image makes an angle of theta with the eyepiece, and the magnification for this is given as F over FE. F हमारे पास क्या है? Objective lens की focal length and eyepiece की length, the ratio of this one. On the contrary, ये उन्होंने image show किया हुआ astronomical telescopes creates a virtual image that is inverted compared to the object. ये हमारे पास objective lens है जहाँ से rays pass out हो रही हैं, parallel becomes converging become, यहाँ पे उसने double उसके अंदर किया हुआ है, and this is the image formed by the वो जिनको ट्रेस बैक किया हुआ। ये देखो लेंस पे आया, कन्वर्जेस, ट्रेस बैक। लेट मी वॉक इट थ्रू। मैं इसको रेस कर देता हूँ सो दैट ओके पैरेलल रेज आए, दे कन्वर्ज टू अ पॉइंट। ठीक है, अब ये रेज जो है वो आगे तक ये ट्रेस बैक कर रहे हैं टू दिस पॉइंट। अगेन जैसे हमने वो शॉर्ट साइडनेस एंड लॉन्ग साइडनेस के अंदर किया था ना, दे कन्वर्जेस, और ये ट्रेस बैक रेज है, ये वाली ट्रेस बैक है, एंड हमारे पास इमेज फॉर्म हो रहा है। ठीक है, अब अगेन टू लेंसेज हैं तो इन्वर्टेड इमेज है, यानी यहाँ पे ये जो इमेज फॉर्म हुआ ये रियल इमेज था, बट इसके लिए इनसाइड द फोकल लेंथ है तो वर्चुअल इमेज हमारे पास आ रहा है ऑब्जेक्टिव लेंस फोकस पॉइंट एंड basically simple telescope is an instrument which is used to observe the distance object using lenses or mirror. A telescope that uses two converging lenses is called refracting telescope. In refracting, an objective lens forms a real image of the distance object while an eyepiece, which मैंने आपको बताया यहाँ पे, nothing else in context. टेरेस्ट्रियल वर्सेस रिफ्लेक्टिंग टेलीस्कोप में क्या डिफरेंस है? टेरेस्ट्रियल टेलीस्कोप के अंदर वी हैव एन एक्स्ट्रा लेंस बिटवीन द ऑब्जेक्टिव एंड आईपीस फॉर द MCQ thing. And the magnification of a telescope, a combination of lenses is equal to the product of the magnification of each lens. Let me take you back to our NBF and see if there is anything else present here. Sorry, this is not the right file. Here you can see in the NBF book, we have exactly the same formulas. There they have mentioned a negative sign alongside with it, just to show that the image is inverted. They might have, it's written also here. बाकी उन्होंने एग्जाम्पल्स यहाँ पे डिस्कस किए हुए हैं वो जो अभी we recently read the statement in the other book. It is a product of the magnification of each lens. So here you could see here magnification of objective lens and magnification of. So the overall magnification of a microscope is the product of the magnification produced by the two lenses and is given by. This is for the objective lens. This is for the आईपीस लेंस. यहाँ पे उन्होंने डिस्टेंसेस को मेंशन आप भी किया होगा LNDI. वहाँ पे हम लोगों ने क्या फॉर्मूला पढ़ा था इन दी अदर बुक? व्हाट वाज द फॉर्मूला? 1 प्लस मैग्निफिकेशन उसकी और उसकी मैग्निफिकेशन को उन्होंने ऐड अप किया हुआ था. ये तो सिंपल माइक्रोस्कोप का फॉर्मूला था. देखो सिंपल माइक्रोस्कोप का फॉर्मूला हम लोगों ने किया था ना कल के. इट वाज जस्ट फॉर वन लेंस 1 प्लस D/F. और compound microscope के अंदर here we could see 1 plus D/F and L/F. So magnification of eyepiece objective lens and magnification जो product यहाँ पे वो mention out की हुई है जो उसने यहाँ पे उसको mention out किया भी था कि the magnification of a lens is equals to the product of the magnification mode. So this is for the objective lens, the focal length, and this is for the eyepiece lens. Basically formulas approximately same ही बन रहे हैं. Let's see one more time कि हमारे पास जो वो था कंपाउंड माइक्रोस्कोप का फॉर्मूला उन्होंने यही दिया हुआ था इन आवर सिंपल माइक्रोस्कोप का. सॉरी, yes, it's written as N plus F plus 1. Do we have any questions so far?
No.
Let's review the solved examples first and let's do the numericals today. The formula first one is a watchmaker uses a magnifying glass of focal length 5 centimeter to view a small part of the near part of distance when is 25 centimeter. Find the angular magnification produced by the magnifying glass at the near point and at an infinity. So near point पे जाएंगे तो हम लोग exactly वही formula use करेंगे N/F plus 1 का. N/F focal length उसने हमें दी हुई थी 25 over plus 1 is equal to 6 and simple angular magnification हमने simple magnification निकालनी है at infinity. जस्ट हम N/F का formula use करेंगे that came out to be 5. So relaxed eye magnification is smaller than the near point distance by 1. अगर हमें ऑब्जेक्ट प्लेस एट इन्फिनिटी पे करना है तो n ओवर एफ है, और अगर नियर डिस्टेंस पे है तो इट्स द फॉर्मूला ये। तो हम लोगों ने इन दोनों के हिसाब से देख लिया। नेक्स्ट क्वेश्चन था हमारे पास, a biology teacher was performing an experiment to view algae to student in a lab using a power microscope. The teacher has near point of distance 25 centimeter. If the objective lens has a focal length of 2, the eyepiece has a focal length of 3, the LG is 2.5 centimeter from the object. अब हमारे पास L over F into 1 plus N over FE का फॉर्मूला यूज होगा। तो आईपीस के लिए उसने डिस्टेंस कितना शो किया हुआ है? आईपीस की फोकल लेंथ ये है, एंड ऑब्जेक्टिव लेंस से उसका डिस्टेंस ये है, एंड ये 25 सेंटीमीटर एन की वैल्यू है यहाँ पे। लेट्स सी उन्होंने ये फॉर्मूला यूज किया है, कुछ और यूज किया है। सबसे पहले उसने डिस्टेंस ऑफ इमेज फाइंड आउट कर लिया यूजिंग दिस फॉर्मूला। डिस्टेंस ऑफ ऑब्जेक्ट वाज गिवन एज 2.5 सेंटीमीटर, उन्होंने यहाँ पे दिया हुआ था। फोकल लेंथ वाज गिवन एज 2 centimeter for objective lens, 2.5 in this. The distance of image came out to be 10 into 1, and distance of image over n over f. N is the least distance of distant point, 10 over 2 into 25 into 3. Magnification came out to be -41, showing us कि वो एक virtual image form हो रहा है। An astronomical telescope has an objective lens FO is 9 centimeter. अच्छा ये लिखी हुई है, I don't need to write it down again. FO is 900 millimeter and the focal length of eyepiece is 20 millimeter. Both have the same units. Angular magnification and appropriate length of the telescope find out करनी है। Length of the telescope totally किसकी equal होगी? It would be equal to the sum of the focal length of objective lens and eyepiece length, because that is the total distance of the telescope. तो इसमें से अगर हम इन दोनों की focal lengths को add कर देंगे, we'll find out the length of the telescope. एंड में उन्होंने किया भी होगा। हाँ, ये लेंथ ऑफ द टेलीस्कोप निकल आई 909, सिंपली उनको ऐड कर दिया। बट मैग्निफिकेशन का फॉर्मूला लगा के हमने टेलीस्कोप की वो फाइंड आउट कर लेनी है। फोकल लेंथ ऑफ ऑब्जेक्टिव और फोकल लेंथ ऑफ आई पीस, आंसर केम आउट टू बी -45। नाउ लेट्स जंप टू द numericals first. Most of the numericals are already solved.